Have you ever looked up at the night sky and felt a profound, almost unnerving sense of solitude? Not just the vast, cold emptiness between the stars, but a deeper, more fundamental isolation. The feeling that this reality, this specific sequence of events that led to you right here, right now, is the only one. It's a feeling baked into our consciousness, the ultimate prison of the self. But what if that feeling is wrong? What if the greatest illusion we live under isn't that we are the center of the universe, but that we are the only universe? For centuries, this idea has been the exclusive domain of philosophy and fiction. Parallel worlds, alternate timelines, realities where dinosaurs never went extinct, where you made a different choice this morning, where humanity took to the stars 1,000 years ago. We treat these as stories, as thought experiments. But here, in the Fronteras de Engenharia Cósmica, we ask a different kind of question. We don't ask, what if? We ask, how? How could humanity, a species still struggling to leave its own planetary cradle, engineer the most audacious, the most reality-defying structure ever conceived? A bridge between universes? This is not a question of magic or metaphysics. This is a question of engineering. It is the quantum blueprint. Before we can even begin to sketch that blueprint, we must understand the nature of the material we intend to work with. And that material is reality itself. The modern understanding of physics, particularly quantum mechanics, has peeled back the curtain on a cosmos far stranger than our ancestors could have ever imagined. The many worlds interpretation, proposed by Hugh Everett III in the 1950s, suggests a breathtaking possibility. It posits that every time a quantum event has more than one possible outcome, the universe itself splits. A decision is not made. Rather, all decisions are made, each branching off into its own separate, equally real universe. Think of it not as a single timeline, but as an infinitely branching tree, a cosmic library containing every book that could ever be written. We are living on a single page of a single one of those books. The engineering challenge, then, is this. How do we build a device that allows us to turn the page? How do we construct a gateway that allows us to step out of our own story and into another? This is a project so vast, it makes building a Dyson sphere look like assembling a child's toy. A Dyson sphere is about harnessing the energy of a star within our own universe. A multiverse bridge is about punching a hole through the very definition of what our universe is. Let's be clear about what we are proposing to build. This isn't a shimmering magical portal that appears and disappears at will. An engineer thinks in terms of structures, systems, and energy. A bridge between realities would be the ultimate megastructure. Perhaps it's a stabilized Einstein-Rosen bridge, a wormhole, a theoretical shortcut through space-time that could, in principle, connect not just 2 points in our cosmos, but 2 separate cosmoses entirely. Or perhaps it's a macroscopic quantum tunneling device, a machine that manipulates the probabilistic nature of reality on a colossal scale, allowing a complex object to probe, a ship, a person to momentarily cease existing in this universe and begin existing in another. Or maybe it's something even more exotic, a structure that generates such an immense density of energy that it creates and sustains a controlled, artificial Big Bang, a pocket universe that serves as a cosmic interchange, a grand central station for the multiverse. Each of these concepts is, by our current standards, functionally impossible. They would require energies that dwarf the output of our sun, materials with properties that defy the known laws of physics, and a level of control over the fabric of space-time that we currently can only dream of. And that brings us to the core of our investigation, the central philosophy of this channel. We stare at an impossible problem, and we see not a wall, but a puzzle. The question we must ask is this: what if the key to building this bridge, the solution to its seemingly insurmountable challenges, is not to be found in our terrestrial limitations, but in the very scale and nature of the cosmos itself? What if the universe, or rather, the multiverse, has left clues, loopholes in its own source code that a sufficiently advanced engineering discipline could exploit? We tend to view the laws of physics as rigid constraints, as prison bars. But what if they are also a set of tools? Gravity bends space-time. Quantum entanglement links particles across any distance instantaneously. Black holes contain singularities where our understanding of physics breaks down completely. Are these limitations, or are they signposts pointing the way? This investigation is a journey to find out. We will proceed not as mystics, but as cosmic detectives, as engineers looking for a foothold in the sheer cliff face of impossibility. Our mission is to draft the blueprint. To do that, we must first fully comprehend the mountain we intend to move. We will begin by dissecting the challenges, piece by agonizing piece, understanding the colossal forces we must tame and the fundamental constants we must bend to our will. We will explore why this project is considered impossible, not to be discouraged, but to map the boundaries of our own ignorance. Then we will search for clues. We will look to the farthest reaches of cosmological theory and the deepest mysteries of the quantum realm for the tools and principles that could make this bridge a reality. We will find the eureka moment, the ingenious connection that turns a problem into a solution. Finally, we will outline the construction itself, a step-by-step speculative plan for the greatest engineering project in human history. This is more than a technical exercise. It is a testament to the human drive to explore, to connect, and to transcend. The dream of building a bridge between realities is the ultimate expression of that drive. It's the refusal to accept that this page is the only page, that this story is the only story. It is the beginning of humanity's journey from a cosmic species to a multiversal one. The investigation starts now. To build the impossible, we must first understand the anatomy of its impossibility. An engineer does not shy away from obstacles. They measure them. They test their tensile strength. They map their every surface. Only then can they find the fracture points. The project of engineering a bridge between realities is not blocked by a single wall, but by a fortress, a series of concentric defenses erected by the fundamental laws of the cosmos. Our first task as investigators is to survey this fortress, to understand the sheer scale of the forces arrayed against us. We will find that these defenses fall into four distinct categories: the barrier of energy, the barrier of space-time integrity, the barrier of exotic materials, and the barrier of quantum stability. Each one on its own is enough to render this project pure fantasy. Together, they form the great intellectual challenge of our species. Let us begin with the most brutal and straightforward of our obstacles, the energy requirement. The famous equation from Einstein, E equals mc2, is often used to describe the immense power locked within matter. But in the context of general relativity, it tells a more profound story. Mass and energy are two sides of the same coin, and it is this combined mass-energy that tells spacetime how to curve. To build our bridge, we are not merely trying to power a machine. We are trying to actively sculpt the fabric of reality. We need to generate a gravitational field so intense that it literally rips a hole in the geometry of our universe. The energy required for such an act is not measured in gigawatts or terawatts, the language of our terrestrial power grids. It is measured in stellar equivalents. A conservative estimate for opening and sustaining a wormhole just 1 meter wide, large enough for a small probe, demands an amount of energy equivalent to the total output of our sun over hundreds of years, all focused into a single point in an infinitesimally short amount of time. And for a bridge large enough for human passage, the numbers become truly astronomical. We are talking about the energy of a supernova, the cataclysmic explosion that ends the life of a giant star. Let's put this into perspective using the Kardashev scale, which classifies civilizations based on their energy consumption. A Type 1 civilization can harness all the energy available on its home planet. A Type 2 can harness the entire output of its home star, likely through a megastructure like a Dyson sphere. A Type 3 civilization can command the energy of an entire galaxy. As of today, humanity is barely a Type 0.7 civilization. The construction of a multiverse bridge would require an energy budget that makes a Type 3 civilization look like it's running on batteries. We would need to be able to capture, store, and manipulate the energy output of thousands, perhaps millions of stars simultaneously. So the first great filter is one of brute force. Before we even address the complexities of the physics involved, we are faced with the simple, crushing fact that we do not have the power. It's like a tribe from the Stone Age trying to conceptualize the construction of a nuclear aircraft carrier. They don't just lack the blueprints. They lack the fundamental prerequisite of fire itself on an industrial scale. This energy barrier is the first and highest wall of the fortress. But let us assume for a moment that we could somehow summon this godlike power. Our problems have only just begun. We now face the second barrier, space-time integrity. General relativity describes space-time as a dynamic, fabric-like medium. It is resilient, but it is not unbreakable. What we are proposing is to perform the most extreme form of cosmic surgery imaginable. Creating a bridge is synonymous with creating a region of what physicists call non-trivial topology. In layman's terms, we are creating a hole. But the universe abhors a vacuum, and it abhors a hole in its fundamental structure even more. Pumping the energy of a supernova into a single point in space is an act of incredible violence. The risk of failure is not that the machine simply doesn't turn on. The risk is creating an uncontrolled black hole that could swallow our entire solar system. A black hole is, after all, a point of space-time curved so extremely that it has collapsed in on itself. A failed bridge that leads only to a one-way trip to oblivion. The gravitational waves, ripples, and space-time itself produced by such an event would propagate outwards at the speed of light, powerful enough to disrupt planetary orbits light years away. It's like trying to perform microscopic brain surgery with a sledgehammer. The tool is powerful enough, but the control required is orders of magnitude beyond the brute force of the tool itself. Any slight miscalculation in the geometry of the gravitational field, any unexpected fluctuation, and our bridge collapses into a singularity or explodes with the force of a gamma-ray burst. The integrity of our own universe is at stake. Now, let's add a third layer of impossibility. Even if we have the energy, and even if we develop the surgical precision to manipulate space-time without destroying ourselves, the known laws of physics tell us that our bridge will not stay open. Think of digging a tunnel through wet sand. The moment you remove a handful of sand, the surrounding pressure causes the tunnel to collapse. The throat of a wormhole is subject to a similar, though infinitely more powerful, crushing force from the tension of space-time itself. The calculations of physicists like Kip Thorne and Mike Morris have shown that a traversable wormhole, one that stays open long enough for something to pass through, can only be stabilized by a substance with truly bizarre properties. It requires a form of matter, or an energy field, that possesses negative energy density, often referred to as exotic matter. This substance would have to be gravitationally repulsive. Instead of pulling things toward it, as all known matter does, it would have to push them away. It would be the cosmic equivalent of anti-gravity. We would need to line the throat of our bridge with this material to act as a stent, propping it open against the crushing pressure of space-time. The problem? We have never definitively observed or contained any macroscopic quantity of exotic matter. The Casimir effect in quantum physics demonstrates that regions of negative energy density can exist on a subatomic scale, but the amount required to stabilize a 1-meter wormhole is estimated to be equivalent to the total mass of the planet Jupiter. Where would we find such a thing? Could we manufacture it? Doing so would likely require manipulating the quantum vacuum itself, peeling energy out of empty space, another task requiring near infinite energy and control. This isn't just a resource shortage. It's a fundamental materials science problem. The very ingredient required by the recipe of general relativity does not appear to exist anywhere in our universe in usable quantities. Finally, we arrive at the fourth and perhaps most insidious barrier, quantum stability. Even if we solve the energy crisis, master gravitational surgery, and discover a source of Jupiter-mass quantities of exotic matter, our bridge might still be doomed. At the smallest scales, the Planck scale, space-time is not a smooth, calm sheet. It's a roiling, chaotic foam of quantum fluctuations. Virtual particles pop in and out of existence, and tiny wormholes and black holes are thought to form and vanish in an instant. Our multiverse bridge, a structure that connects two realities, would be a beacon in this quantum storm. Physicists have theorized that the connection point between two universes would be subject to a catastrophic feedback loop of virtual particles. A particle and its antiparticle could pop into existence, with one falling into the other universe while the other remains. This would create a runaway energy surge that would cause the bridge's ends to collapse into black holes, severing the connection in less than a trillionth of a second. The universe, it seems, has a built-in defense mechanism against the paradoxes and causal violations that such a bridge might introduce. It fights back on the quantum level, using the very uncertainty of its nature to destroy any attempt to violate its integrity. Controlling this quantum foam, stabilizing a connection against this infinite storm, is an engineering challenge so profound that we currently lack even the language to properly describe it. It would be like trying to build a sandcastle in the middle of a hurricane. The very environment in which you are building is fundamentally hostile to the existence of your structure. These four walls: energy, integrity, materials, and stability are the reasons why a bridge between realities remains the domain of science fiction. They are, for all intents and purposes, the laws of nature telling us, you shall not pass. An investigator who is deterred by the initial evidence of impossibility will never solve the case. We have surveyed the fortress and found its walls to be high and thick. The brute force of the energy requirement, the delicate fragility of space-time, the demand for unobtainable materials, and the chaotic storm of the quantum realm, these are the guardians of our prison. But now, we change our approach. We are no longer mapping obstacles. We are hunting for clues. We are searching for natural phenomena, theoretical loopholes, and cosmic precedents that hint that these walls are not as solid as they appear. The universe is ancient and vast, and in its extreme conditions, it has performed experiments we can only dream of. Our task is to study its lab notes, to find the evidence that what seems impossible for us is, in fact, commonplace for the cosmos. This is the search for the universe's hidden blueprints. Our first clue addresses the most imposing barrier, the colossal energy requirement. We established that powering our bridge would require the energy of a supernova, a feat far beyond galactic-scale Type 3 civilization. The clue does not lie in how we could generate this power, but in how we could harvest it from a pre-existing source. The universe has already created power plants of unimaginable efficiency and scale, spinning supermassive black holes. A Kerr black hole, a rotating black hole, is not just a point of no return. It is a colossal flywheel of stored energy. Its rotation drags the very fabric of space-time around with it in a vortex called the ergosphere. The Penrose process, a thought experiment from Sir Roger Penrose, showed that it is theoretically possible to extract energy from this region. Imagine throwing a payload into the ergosphere and having it split in two. One half falls into the black hole, while the other is ejected with more energy than the original payload had. This is not magic. It is a transfer of the black hole's rotational energy. A more plausible engineering approach might be the Blandford-Zayat process, where the powerful magnetic fields in the accretion disk of a black hole are twisted by its spin, creating colossal jets of energy that shoot out from its poles, turning the black hole into a galactic-scale electric dynamo. A single large, rapidly spinning black hole can have more rotational energy than the combined light output of all the stars in the Milky Way galaxy over 1,000 years. Here, then, is our first clue. The energy problem is transformed. It ceases to be a problem of impossible generation and becomes a problem of cosmic scale harvesting. The engineering challenge is no longer how to make a star explode, but how to build a power station around a black hole. A monumental task, yes, but one that shifts from the realm of the physically forbidden to the realm of the technologically ambitious. With a potential power source identified, we turn our investigation to the second barrier, space-time integrity. We fear that our attempts to sculpt space-time will shatter it, creating a catastrophic black hole. But what if the universe has already done the delicate work for us? What if the bridges we seek to build already exist on a microscopic level? This is where our investigation takes a turn into one of the most exciting and speculative areas of modern physics, the E equals EPR conjecture. This idea, born from the minds of Leonard Susskind and Juan Maldacena, proposes a deep connection between two seemingly unrelated quantum phenomena. On one hand, we have Einstein-Rosen bridges, A, the original name for wormholes. On the other, we have Einstein-Podolsky-Rosen paradox, EPR, more commonly known as quantum entanglement, the spooky action at a distance, where two particles remain connected, no matter how far apart they are. The conjecture suggests these are the same thing, that every pair of entangled particles is connected by a microscopic, non-traversable wormhole. If this is true, then the universe is not a single solid sheet of spacetime. It is a quantum tapestry woven together by an infinite number of these tiny threads, these micro wormholes. Our universe is already connected to itself in ways we can barely comprehend. This clue is profound. It means our engineering task might not be to violently punch a hole in reality. Instead, it might be to find one of these pre-existing quantum threads and carefully, surgically, inflate it. We would need to feed it vast amounts of energy, the very energy we've learned we can harvest from a black hole, to widen its throat and stabilize it, turning it from a subatomic, non-traversable connection into a macroscopic, traversable bridge. The problem of spacetime integrity is reframed. It is no longer cosmic demolition. It is quantum angioplasty. This leads us directly to the third wall, the need for exotic matter with its gravitationally repulsive properties. The universe seems devoid of this unobtainium required to prop open our bridge. But is it really? For decades, astronomers have been grappling with a mystery. The expansion of the universe is accelerating. Some unseen force is pushing everything apart, counteracting gravity on the largest scales. They call this force dark energy. While we don't know what dark energy is, we know what it does. It exhibits a negative pressure, acting as a cosmic anti-gravity. In essence, dark energy is the universe's own, naturally occurring form of exotic matter. The clue is this: the effect we need to engineer on a local scale already exists on a cosmic one. The universe itself provides a proof of concept. The challenge, then, is not that the physics is impossible, but that the resource is diffuse. Dark energy is spread thinly across the cosmos. So, the engineering question evolves. Can we learn to harvest and concentrate dark energy? Or, more plausibly, can we learn to replicate its effect? This is where a clue from the lab comes into play, the Casimir effect. This verified phenomenon shows that if you place two uncharged metallic plates extremely close together in a vacuum, a force will pull them together. This is because the empty space between the plates is restricted in the quantum wavelengths it can contain, resulting in a lower energy density compared to the space outside. This region of lower energy density behaves exactly like the negative energy required to stabilize a wormhole. The effect is minuscule, but it is real. It proves that we can, in fact, engineer the properties of the quantum vacuum. So the solution to the exotic matter problem may not be to find a magic material, but to build it, or rather, to create the conditions for it, to engineer the vacuum itself into the configuration we need. Finally, we must confront the fourth barrier, the quantum storm that threatens to annihilate our bridge in an instant. The feedback loop of virtual particles seems to be a fundamental and unavoidable consequence of connecting two universes. How can we possibly stabilize a structure against the very chaos of existence? Our final clue comes from one of the strangest principles in quantum mechanics, the quantum Zeno effect. The name comes from the Greek philosopher Zeno's paradoxes about motion. In the quantum world, it refers to a phenomenon where the act of repeatedly measuring a particle can prevent it from changing its state. It's as if the universe, when being watched closely, becomes shy and freezes in place. The popular analogy is a watched pot never boils. If you could observe a radioactive atom with sufficient frequency, you could, in theory, prevent it from ever decaying. This is not science fiction. It is a demonstrated effect in quantum optics laboratories. Herein lies our most subtle and ingenious clue. What if we could apply the quantum Zeno effect to the throat of our bridge? By building a sensor array of unimaginable precision, one that could observe the state of the space-time geometry on a continuous basis at the Planck timescale, we could potentially freeze the bridge in its open state. We could effectively hold back the quantum foam, preventing the virtual particle feedback loop from ever gaining momentum. It would be the ultimate act of control systems engineering, using one of the most counterintuitive aspects of quantum mechanics as a weapon against the destructive nature of quantum mechanics itself. The poison becomes the antidote. The very source of the instability provides the blueprint for the stabilization system. The challenge is no longer one of being overwhelmed by a quantum storm, but of building a sufficiently advanced quantum weather satellite to predict and quell the storm before it can even form. The impossible problem of stability now looks like a problem of information and measurement. This is the pivotal moment in our investigation, the point where disparate clues, gathered from the farthest reaches of theoretical physics, converge into a single, coherent picture. For every impossible problem, the universe has shown us a corresponding, equally powerful clue. The novice sees them as a collection of interesting but unrelated facts. The engineer sees them as the components of a machine that has not yet been built. Our task now is to assemble them, to move from investigation to synthesis, to formulate the technical thesis at the heart of our quantum blueprint. This thesis is a radical departure from conventional engineering. We will not build a bridge in the traditional sense. We have established that brute force is doomed to fail. Instead, our thesis is this: a bridge between realities is not a structure we build, but a natural phenomenon we must learn to cultivate. Our blueprint is not for a static object, but for a dynamic, living system, a cosmic-scale garden, where we will plant a quantum seed and nurture it into a macroscopic gateway. Let us begin by formulating the core of our solution, which addresses the conjoined problems of energy and spacetime integrity. Our first clue was the immense power of a spinning Kerr black hole. Our second was the E equals EPR conjecture, suggesting that entangled particles are already connected by micro wormholes. The ingenious connection is to use the first clue to enable the second. The work site for our project will be the ergosphere of a carefully selected, rapidly spinning supermassive black hole. Here we will construct our power plant, a Blandford-Zayek dynamo ring. This megastructure would encircle the black hole, using vast superconducting coils to interact with the magnetic fields of its accretion disk. As the black hole spins spacetime, it twists these magnetic fields, generating electrical currents of stellar magnitude. This dynamo gives us the near limitless, and more importantly, controllable energy source we require. But the black hole is not just our power plant. It is also our crucible. Within the intense, warped spacetime near its event horizon, we will use this harvested energy to achieve our first great feat, the creation of two entangled microscopic black holes. According to the E equals EPR conjecture, the moment these two singularities are born entangled, a natural, stable, but non-traversable Einstein-Rosen bridge forms between them. This is our quantum seed. We do not create the bridge through violence. We coax it into existence by exploiting a fundamental property of quantum gravity. We then have the two ends of our bridge. One remains at our primary worksite, while the other, still microscopic, can be carefully transported perhaps in a specialized magnetic containment vessel to our desired destination. whether that is across the galaxy or, theoretically, into a different brane in the multiverse. The problem of ripping spacetime apart is thus circumvented. We have allowed the universe to do the hard work of weaving the connection for us. Now we have our seed, a microscopic and useless thread connecting 2 points. Our next challenge is to make it grow, which means solving the exotic matter problem. The bridge will collapse if we try to widen it without propping it open with gravitationally repulsive negative energy matter. Our third clue was that this effect is real, evidenced by cosmic dark energy and the laboratory-verified Casimir effect. The ingenious connection here is to realize that exotic matter need not be a substance we find, but an environmental condition we engineer. We will not build our bridge out of a magic material. We will build a machine that creates the conditions of negative energy on demand. To do this, we will construct Casimir stents at the throat of our microscopic wormhole. As we begin to carefully feed energy into the wormhole's mouth from our dynamo ring to inflate it, these stents rings of hyper-advanced metamaterials and fantastically powerful electromagnetic field projectors will activate. Their purpose is to manipulate the quantum vacuum within the bridge's throat. By creating precisely configured electromagnetic cavities, they can exclude certain quantum vibrational modes from the vacuum, just like the plates in the Casimir experiment. This creates a localized region of intense negative energy density, a self-generating field of exotic, gravitationally repulsive spacetime. This field pushes outwards, counteracting the bridge's natural tendency to collapse. It is an active dynamic process. The bridge is not held open by passive struts, but by a constantly maintained, power-hungry vacuum energy configuration. The more we widen the bridge, the more power we must pump into the Casimir stents to maintain the negative pressure. The Jupiter mass of exotic matter is no longer something we must find, but something we must simulate through a colossal expenditure of energy, supplied directly by our black hole power plant. The materials science problem has been converted back into an energy problem, which we have already solved. We have a powered up, inflated, and stabilized bridge. But it is a structure living on a knife's edge, threatened by the fourth great barrier, the quantum foam and the virtual particle feedback loop. It is a sandcastle against the tide of quantum chaos. This is where our final clue, the quantum Zeno effect, becomes the linchpin of the entire system. The ingenious connection is to recognize that the bridge's stability cannot be passive. It must be the result of a continuous, active, an intelligent process of observation and correction. The bridge is not an object. It is a controlled state of being. Woven into the Casimir stents is our final piece of hardware, the Zeno Guardian Array. This is a sensor network of unimaginable sophistication, capable of monitoring the quantum state of the wormhole's throat at timescales faster than a single Planck time. It is, in effect, constantly watching the bridge's existence. The moment a virtual particle pair threatens to create a runaway feedback loop, the Guardian Array detects the incipient fluctuation. Before it can cascade, the system fires a microscopic, precisely targeted pulse of energy from the dynamo ring, which resets the local quantum state, effectively collapsing the waveform of the instability before it can begin. The bridge is held open by a self-correcting feedback loop that uses the principle of observation to enforce stability. It is the ultimate expression of control systems engineering. We are using the universe's own rules about observation to prevent it from dissolving our creation. The quantum storm is not calmed. It is perpetually held at bay, frozen in the first moment of its formation by a vigilant, never-blinking eye. This system transforms the bridge from an impossibility into a machine that requires constant power, constant maintenance, and constant computation, but a machine nonetheless. This, in its entirety, is our technical thesis. The quantum blueprint is a plan to cultivate a naturally occurring quantum entangled wormhole, inflate it with the energy of a spinning black hole, and keep it stable by actively engineering its vacuum energy and perpetually observing its quantum state. It is the grand synthesis of our investigation. A blueprint, no matter how brilliant, is merely a dream on paper. The final test of any engineering endeavor is its translation into steel, energy, and action. Our technical thesis is sound. It connects the impossible problems to the universe's own hidden solutions. Now, we move from the role of detective to that of architect and project manager. How would humanity actually build this quantum blueprint? The process would be, without question, the most complex and lengthy undertaking in the history of our species, a multi-generational project spanning millennia and light years. It would unfold in a series of meticulously planned stages, each one a giant leap for civilization in its own right. The first stage is site selection. We cannot build our cosmic engine just anywhere. We require a very specific type of black hole, a supermassive, rapidly spinning Kerr black hole, but one that is relatively quiescent. A raging quasar, while powerful, would sterilize any construction effort within 1,000 light years. This stage would begin with the launch of a fleet of eye-driven interstellar probes, Sky Great Survey, to map the promising candidates in our local galactic neighborhood. For centuries, these probes would travel, collecting data on black hole mass, spin rate, the A parameter, accretion disk stability, and the local resource environment, such as asteroid belts or gas giants ripe for mining. This phase alone would represent a massive expansion of humanity's presence in the cosmos, pushing our sensor capabilities and long-duration spaceflight technologies to their absolute limits. The final selection would be the most important real estate decision ever made, choosing the foundation stone for our bridge to infinity. Once the site is chosen, Stage 2 begins, the establishment of a cosmic industrial base. It is ludicrous to imagine building a megastructure light years away by shipping materials from Earth. The only feasible method is in situ resource utilization on an unprecedented scale. This is the domain of the von Neumann probe. We would send a single highly advanced self-replicating robotic factory on a millennial journey to the target system. Upon arrival, its prime directive would be to use the raw materials of that system, the asteroids, the comets, the atmospheric gases of unclaimed planets, to build more factories. And those factories would build more factories. Over the course of 1,000 years, a single seed probe would blossom into a vast, autonomous industrial ecosystem, an armada of construction drones, refineries, and fabricators. This robotic civilization would become the true builder of our bridge, a testament to humanity's ability to project its ingenuity across the stars. This phase is the slow, patient work of laying the foundations, turning a barren star system into the single greatest manufacturing center in the history of the universe. Stage 3 is the assembly of the dynamo ring. With the industrial base operational, the robotic workforce turns to the primary construction. Swarms of drones would mine trillions of tons of iron, nickel, and silicates from asteroid fields, refining them into the exotic alloys and superconducting materials required. They would fabricate the colossal magnetic coils, the plasma converters, and the structural supports of the Blandford-Zayat dynamo ring. Imagine rings of shimmering metal and light, each component the size of a small moon, being assembled in the void by a silent ballet of machines. These rings would be constructed in a safe orbit before being carefully, painstakingly maneuvered into the maelstrom of the black hole's ergosphere. This would be the most dangerous and precise maneuver ever attempted. A cosmic dance where a single miscalculation could see a century of work devoured by the black hole. The moment the dynamo ring activates, tapping the rotational energy of the black hole and channeling it, marks the true dawn of humanity as a Type 2 and arguably Type 3 civilization. We will have harnessed a cosmic god. Stage 4, the final and most delicate phase, is the cultivation of the bridge. With a virtually limitless power supply, we execute the core of our thesis. The robotic systems create and entangle the two microscopic singularities. One is kept locally, while the other is sent on its journey to the destination. Around the local mouth, the Casimir stents and the Xeno Guardian array are assembled. Then the process begins. Energy is slowly, carefully fed into the microscopic wormhole. The process is not like flipping a switch, but like nurturing a seedling. For decades, perhaps centuries, the energy flow would be minutely increased, widening the throat of the bridge by fractions of a millimeter per year, while the xenoarray works constantly to maintain its quantum stability. The first sign of success would be the transmission of a single information-encoded photon, then a stream of data, then a microscopic probe. Each step would be a victory celebrated across generations. The day the bridge is stable enough and wide enough to transmit a human-sized object is the day the project is complete. It is the day history ends and a new, unimaginable story begins. And what is the legacy of such a project? If the construction is the climax of our engineering story, its completion is the preface to a new Bible for humanity. The impact would be total, redefining every aspect of our existence. Economically, it marks the end of scarcity. With access to potentially infinite universes, we gain access to infinite resources. We could find entire planets of rare metals in lifeless realities, harvest energy from stars in empty universes, and expand our civilization without limit and without ecological consequence to any living world. Philosophically and socially, the impact is even more profound. What happens to our sense of self when we can meet other versions of ourselves who made different choices? What happens to our religions, our histories, our cultures, when we discover they are but one variation among a billion others? We would be confronted with the ultimate mirror, forced to see every path not taken, every success and every failure of every possible humanity. The potential for schism, for existential crisis, is as immense as the potential for enlightenment. The bridge would be the source of our greatest art, our deepest philosophy, and perhaps our most terrible conflicts. Scientifically, the bridge is the ultimate tool. It is a laboratory where the fundamental constants of nature are the variables. We could study physics in universes with different laws, stronger gravity, more spatial dimensions. We could finally answer the question of whether our universe is fine-tuned for life, or if life is an emergent property in countless cosmic configurations. Cosmology would cease to be an observational science and would become an experimental one. But the ultimate legacy is the redefinition of survival. As a species, we are bound to the fate of this universe, destined to end in its eventual heat death. The bridge changes this. It is our escape hatch. It is the guarantee of civilization's immortality. When our stars begin to fade, we can simply cross the bridge to a younger, more vibrant reality. Humanity would cease to be a species bound to a single cosmos. We would become a multiversal civilization, travelers of eternity. The completion of the quantum blueprint is not just the greatest engineering feat imaginable. It is the final step in our evolution, the moment we transcend our cosmic cradle and inherit the stars in their infinite variety. It is the beginning of our true legacy.